Welcome to Green Numbers Data Tutorials. In this video, I'm going to show you how to get started in SAS. Most people learn best by doing, and my goal is to show you a sample of useful examples. Hopefully this video will give you enough information without overwhelming you so you can start practicing. So let's get going. On the screen here you see SAS Studio. It's very similar to base SAS. The code, log, and results in base SAS are along the bottom in tabs. The code is the text editor where you type your code to manipulate data and run statistics. The log shows you the output of the code you ran, helps you to decipher and work through errors and warnings, and results shows output from some of the code that you run. And I'll show you examples of all of these as we move through this video. Along the left-hand side here are the server files and folders. This is where you can find SAS code that you've already written. For example, you see here that I've written one named test.sas. And on the bottom here, you see libraries. This is where you can find data sets that you create, data sets that are already created. I'm going to show you how to create a library. I'm going to show you how to create a data set and store it in a library. But to start out, we're going to look at the SAS help library, which is part of the SAS software. And there are several data sets in here, and we're going to look at one of them in particular, and that's baseball. So if I open that up, we'll take a look at it over here. You can see that this is what's referred to as a SAS data set. And if you come from R or Python, it's analogous to a data frame. If you come from the database world, it's analogous to a table. So along the top are what's called variables in SAS. These are the columns: name, team, number at bat, number of hits. This is a data set for the 1987 baseball season, and it has a number of different statistics. Here is the league, the division, the position, some salary information at the end. And if you look over here, we can click on some of these columns, some of these variables. For example, if we click on name, you see that the name of the variable is name. It's a character variable. It has an 18-character limit and has a label, player's name. And all of these variables are either character or number. If you look at some of these, for example, the number at bat, it's a numeric field. It also has a label, times at bat in 1986. And along the side, these are called observations in SAS, and the 1, 2, 3, 4 over here alongside looks kind of like an index, but that's not what it is. It's not. And the number 1 isn't assigned to Andy Allenson. If I click over here and sort name, you see that the name changed, but the observation number stayed the same. I also wanted to point out that when values are missing or blank, that in numeric fields are represented by a dot or period. I don't think there are any examples in this data set of blank text values, but blank text values are just blank. So what if we just wanted to isolate players who played for Cleveland? Well, there are lots of ways to do that in SAS. I'm going to show you one of them. And the main way that people do this in SAS is by using the data step. And the data step starts out with the word data. That lets SAS know that you're about to use the data step. Then we're going to name, in this example, we're going to name the output data set. And because we're isolating Cleveland players, let's just make it simple, call it Cleveland. And all SAS statements end in a semicolon. And now we need to tell SAS what input data set we're going to use. So as I said over here, we're using the baseball from the library SAS help. So we use what's called a set statement. We type in set, we tell SAS what library we want to use, type in the word baseball, end it with a semicolon, and now we type the word run. We use a run statement. A run tells SAS that the data step is finished and tells it to run the code in the data step. And we're just going to do that now. So if I, this running man right here, or press F3, which I'm going to do now, it runs the code. And let's take a look at the log. We see that there were 322 observations read from SAS Help Baseball, and our new data set, work.cleveland, has 322 observations and 24 variables. So it copied SAS Help.baseball verbatim without any changes. And we can see that if we look over here in the work library, we see that a new data set is created named Cleveland. So the work library is a temporary library. So at the end of this SAS session, everything that's in the work library goes away. And for the most part, that's fine, right? We have SAS.help.baseball and we have our code, which we're going to save at the end here. And if we just open up our code and run it, in less than a second, we recreate the Cleveland data set. But say, for example, that our input data set changes over time and we're looking to get a snapshot. So what we want to do is we want to save it permanently in a library. And this is relatively easy to do. In base SAS, you type in the word lib name, and then you call your library something. Let's call it my data, and then we put in a path. So for example, I made a path in my C drive named, or a folder in my C drive named SAS. So I'm going to paste that in there. And if I ran this, I would create a library named my data over here that I could store stuff in. But because I'm in SAS Studio, it's a little bit different. It uses a virtual session, and the library or the folder structure you set up is set up during the installation. And for most, the default is as follows. So it's folders, /folders, /my folders. And in my folders, I created a folder named project. So I'm going to comment this out. So I put an asterisk at the beginning of this line. That tells SAS to ignore this line so it won't run. You can also use this, and you should use this, to annotate your code. Like, for example, you might want to say, this code generates a data set with Cleveland players. You know, something like that. This helps you, when you look at your code, know what it's doing. It helps others if they were to look at your code as well. So if I highlight this lib name statement and run it, we see that it was created successfully. We see the library my data over here. So it worked. So if I wanted to save Cleveland permanently, I can copy that, put it in front of Cleveland, and then if I run that, all right, we see that the dataset Cleveland was created permanently in the My Data folder library. But what we're doing today, we don't need to save it in a library. Let's just get rid of that. I'm just going to get rid of this too just for this exercise here. And so we decided that we wanted to create a data set just with Cleveland players. So let's use an if statement. So we'll say if team equals Cleveland. So we're using an if statement, and we're using this operator equal. Instead of the EQ, you could also use this equal. If it's a number, a numeric field, which this is not, you could use lesser than, you could use greater than, you could use greater than equal to. But I like to use the characters. There's also, in addition to equal, there's also greater than, there's less than, greater than or equal to, less than or equal to. So I'm going to use equal here. Let's run this and take a look. All right, we did it. We see that in a work library, we have the data set Cleveland. Here's the output. We see that all of the players in this data set are Cleveland players. So what if we wanted to isolate Cleveland players and Boston players in the same data set? So what we would do then is we would say if team equals Cleveland or team equals Boston. We ran that. There we go. So now we see a new data set that has Cleveland and Boston players in it. What if we wanted to just isolate Cleveland players whose salary is greater than $500,000? So we would say if team equals Cleveland and salary greater than 500. The salary column is in increments of 1,000, so you have to multiply by 1,000 to get the true value. And the salary field is numeric, so you don't encase it in quotes like you would a text field. And text fields are literal. You have to take the value exactly as they appear in the data set. If we had changed, instead of Cleveland with the capital C, we made everything a capital, then we would not return any records. Blank. So let's undo that. And let's run this with the salary greater than 500. We see now we have Cleveland players with salary. Let me run over here. Salary greater than 500. So to make this a little bit easier, let's just keep 3 of the columns. So if we wanted to just keep name, team, and salary, we use the keep statement. So we'll say keep name, team, salary. Let's do that. Run it. All right, now we just have name, team, and salary. So what if we wanted to put Cleveland players and Boston players in 2 different data sets? What we would do is in the data statement, we would create 2 data sets, one for Cleveland and one for Boston. And then in our if statement down here, we would say if team equals Cleveland, then output Cleveland. And then we'd say else if team equals Boston, then output Boston. And if we run that, all right, this is only outputting the Cleveland data set in our output data. But if we look at the log over here, we see that 2 different data sets were created, a Cleveland that has 12 observations and a Boston that has 10. If we look at our work library, we see that Boston and Cleveland data sets were created. So what if we wanted to combine data sets? What if we created Cleveland and we created Boston. What if we wanted to create one data set that has both of those with the 2 data sets we just created? Let's put those in the set statement. And now, so we put both of those data sets here in the set statement. We created one variable. I know this looks the same, but I connected it with an underscore. This is one data set right here. Now we have this that is getting in the way of what we want to do. So let's delete that. Run this. There we go. See, a new data set named Cleveland underscore Boston was created. If we go to our log, we see that the new data set Cleveland.Boston has 22 records. Look at our output data set. We see that Cleveland and Boston players are both in the data set. So if we look at our data set, let's look at the name. See, the name, it has combined first and last name. What if we wanted to pull out the last name and pull out the first name and put them in 2 different variables? So let's do that. So let's create a new variable. We're going to call it first name. We're going to set that equal to something. So in this case, we saw that there's a delimiter in here, right? Comma and space, which delimits these 2 different values. So in order to get the first name, we see that first name is last over here. So what we can do is use the scan function, which looks at the value that we're pulling from. We tell SAS which value on which side of the delimiter that we want to assign to first name. So we're using the variable name. We want to take the second value using this delimiter. So we put down the second value on there, and now we tell SAS what the delimiter is. So in this case, it's a comma with a space, with the end with a semicolon. And in order for first name to show up, we got to put it in this keep statement, right? So it shows up. Let's run this. There we go. We have a first name. See, Andy, Andre, Brett, Brooke. All the first names are assigned here. You could also do the same thing by putting in -1. So -1 goes in from the back side, the right side, and goes in the other direction. So -1 would give us the same value. Let's check that out and see. And it does. We get the first name, the same values there. All right, let's do the same thing for last name. I'm going to borrow this line here, copy it down here. Oops. Let's change this to last name. And this time we want the first value listed in the name field. So let's go ahead and add last name to our keep statement. Run that. There we go. First name and last name. So let's say, for example, that we didn't have this name field, that all we had was first name and last name, and that we want to put first name and last name together like we had in that name field. So let's call this our new variable first underscore last, and we're going to use a concatenation function, and there are a number of them. We're going to use one named catx, which allows us to put back a delimiter. So we're going to establish the delimiter first. We're going to say comma space, just like it was before. Now we're going to list the first value that we want to concatenate, which is first name, and then the last value, which is last name. We'll put a semicolon at the end. Oh, got to make sure we put that in our keep statement. There we go. We have a new variable called first last with last name first and then first name second, just like we had in that original. All right, then if we wanted to just keep the first initial, say for example that we want to just keep for the first initial of first name. Let's create a new variable called first init, and we're going to use the substring function. And we're going to pull that first initial from first name. And what we're going to do is we're going to say start at position 1, so the first character, and then grab all of the characters from position 1 to position 1. Now we could, for example, put in position 5. We could say grab all the characters from position 1 to position 5, but we were just looking for the first initial. So we're going to say 1. We could also tell SAS start at position 3 and then grab the first 2 characters starting at position 3. But that's not what we're doing here. Let's put in 1, comma 1. We'll put in our semicolon at the end. We'll add first init to our keep statement. Run it again. And there we go. We have the first initial of the first name of the player. So what if the team names were not standardized? We see that all the team names start with a capital and all the rest of the values are undercase. The first letter of each word in the team. What happens if it's a free text field, right? In those cases, sometimes all of the characters could be uppercase, all could be lowercase, all could be mixed case. And then if we did our if statement, if team equals Cleveland, then we would only get the records where Cleveland was spelled that way. So one way to get around that is to create another variable called, let's call it team upper. And that way we'll create this new variable where we'll make all of the teams uppercase. So we use the function upper on team. That creates a new variable. Let's get rid of all this name stuff. We don't need that right now. And let's get rid of salary too, so we can just compare team and team upper. Ooh. Oh, wrong function. It's actually upcase. Let's try that again. There we go. See, now all of our teams are now in uppercase, and so if they were in mixed case or in uppercase or all in lowercase before, now they're standardized. Now they're standardized all the same, so we could say over here, we could use uppercase here because all of them are uppercase in our new value right here. Let's put it down here. Run that. There we go. Also, you don't have to create this a new variable. In fact, it's better, more efficient if you don't. You can just put the uppercase function in front of team. Right? So we're telling SAS to look for cases or look for records where team is Cleveland, but the uppercase value. So this is a little bit of a shortcut that you can use for a lot of different functions. So what if we wanted to make the first name of the player more descriptive? So when we want to do that, we can create what's called a label. So we could say label first name equals, let's give it something more descriptive, first name of player. So now we run that. We click on first name here, we can see there's a label here. So when we run proc print, other functions that generate output, we can have the option of putting that label in instead of some of these values. For example, if we looked at baseball in here, like some of these variable names are not very descriptive. Some people might not know what they mean. And labels really help, especially when you're generating reports. Likewise, when we look at the salary field, salary variable over here, it's a salary, but there's no dollar signs. It's not really standardized in any kind of way. Let's standardize that salary field. Let's go ahead and put a format on it. So what you can do is you can say format salary. And let's format it as $10. And the formats all end, well, I shouldn't say end, they all have a decimal, a dot after them, indicating that it's a format. So if I do this, apply this format, I got to put salary in there, don't I? The keep statement. Let's look at that. So now we have salary, but now it has this dollar sign and indicating that this is a money field. If we wanted to add the decimal places at the end, we could put a 2 in there, and that adds 2 decimal places because some of those values had some decimal figures as well. Let's run this again. There we go. So now we have 2 decimal places on there for all those values. So let's go ahead and look at some procedures. And the first procedure I want to show you is proc sort. And to do that, let's get rid of this stuff here. And let's create a data set just called baseball. We want to replicate that SAS help baseball data set, but we can't change the SAS help data set. It's a read only. So let's create one that we can work from. Let's get rid of this keep statement. We don't need that. Let's run that. All right, that data set was created. So in order to run proc sort, let's undo this. We type in the word proc sort, and proc means procedure, so it's a sorting procedure. We're going to use the data set baseball. We could type this in as work.baseball, but the default, without putting in the library, is the work. We're going to sort by team. So right now we look at baseball. Let's close this down here. Bring this to the beginning. See, team is not sorted over here. Let's run a sort procedure on that. Let's close this down. There we go. Now we have teams sorted. We can also sort by team and name. So Atlanta, within Atlanta, these names aren't sorted. So let's add name, run that. There we go. Now it's sorted by team and by name. We can also sort by descending name. Let's put in the word descending in front of name. Run that. Now we can see that it's still sorted by team first, so Atlanta is first, but the names within the team are sorted in reverse alphabetical order. And proc sort is useful for a lot of different things, especially in deduplication. So another procedure I wanted to show you was proc print. So if you wanted to print the contents of a data set, you can do it using proc print. So let's print data equals Cleveland. Let's do that. Let's say run. This is going to print everything in the Cleveland data set. There we go right here. So, and what you can do is you can copy this. This is HTML output. And you can go to an Excel spreadsheet. You can paste it in there. This keeps the formatting. If you choose the default, you can press the right key and do the match destination formatting, and do a little formatting here in Excel, and then you have something that looks like a table that you can use as a starting place for some kind of report you want to generate. But if all we wanted to do was get Cleveland from the baseball data set, we don't need to do this data step portion at all. We could say data equals SAS help.baseball, and we could use the where statement. We could say where team equals Cleveland. Print that. Right? We get this, just the Cleveland records from that baseball data set. We can also add the label option up here. So instead of our variable names, we're going to get the labels. See, so a little bit more descriptive. You can see here that the OBS numbers are printed in here as well. Those don't really mean anything to us. Let's get rid of those. You can also add the no OBS option in there. Run that. Now we get the output without those observations. If we only wanted certain fields, certain variables, we could do something similar to the keep statement. We could use the var statement. We could say, well, we only want name, team, and salary, just like we did in the data step up there. And if we run this, now we have our output, our print output with just the player's name, the team, and the salary. We can also add a title 1. Let's call it Cleveland Players. We could run that. There we go. We got an output data set named Cleveland Players. All right, the next procedure I want to show you is proc freq. So it's a frequency procedure. And for this one, we're going to look at a different data set, sashelp.cars. So first, we're going to look at the variable make. So let's put that in there. Let's put our run in there. We're going to run this. Let's take a look at the output. So in our results tab, we see that there is a frequency listing of the make of the automobiles included in this data set. And let's take a look. Let's open this data set up. Here it is. We can see that it has the make, the model, the type, the origin, drivetrain, MSRP, invoice, a bunch of different things. And what we focused on was just the make. And this shows you the frequency. So there were 7 records of Acura in this sashelp.cars data set, 19 for Audi, 20 for BMW. I think that means models. So there's 7 different models of Acura, 19 models of Audi, 20 of BMW, so on and so forth. This is showing them in alphabetical order for make. What if we wanted to look at the frequency from highest to lowest? For that case, let's use the order equals freq option. Run that again. There we go. We see the frequency listing from highest to lowest. So the frequency is listed here. The percent is listed here. This is the percent of total. So 28 of 428 is 6.54%. This is the cumulative frequency. So it's 28 matches this. And so this one is 28 plus 27 equals 55. 55 plus 26 equals 81, so on and so forth. The cumulative percent is similar to the percent over here. It just sums the cumulative frequency. So we can also look at make by type. So a two-dimensional table. Let's output that and take a look. So now we have the make on this side, and along the top we have the type. So Toyota has 16 sedans, 5 SUVs, 2 sports, 1 wagon, 3 trucks, and 1 hybrid for a total of 28 in all. And 16 Toyota sedans is 3.74% of all the records in the data set. It's also 16 sedans is 57% of all of the types of Toyotas. And then Toyota is 6.11% of all of the sedans in the data set. But what if we don't want all this total percent, row percent, and column percent stuff? What if we just want to focus on the frequencies? Let's get rid of those things. So we put in an option here. We say no call, no row, no percent. Run that again. And there we go. We just get the frequency output. So we can also isolate cars on different using a where statement. So, for example, let's use where origin equals Asia. Let's go down to our frequency. We'll put a where statement in here. Origin equals Asia. We'll run that. Now we have the output again, but just for the mix where the origin was in Asia. We can also add a title. Let's put a title in here. Title 1. What do we call this? Make by type. We can also add another title underneath Title 1. Title 2, that is, I don't know, origin in Asia. Let's run that. There we go. See, we have the 2 titles up here. Let's go ahead and add a label as well. So let's say label, what do we call it? Let's say label make. Let's call it company, right? These are companies. Company. We'll run that. There we go. So in the make, it also lists the word company. Sometimes it's good to add a little bit more descriptive information. And the last procedure I want to show you is proc means. It's a descriptive procedure. And let's go back to baseball for this. Remember, we created a baseball data set, work.baseball. Let's just go ahead and use that one here. So for this, let's tell SAS what variable we want to run proc means on. So let's put in salary. Go ahead and run that. You can see that there are 263 observations. The mean salary was 535. The standard deviation was 451. The minimum salary was 67, and the maximum salary was 2,460. There are a lot of things you can do with means, proc means, that I won't get into. Same for proc freak. There's a whole bunch of different things, and I encourage you to look for more videos where I go into more detail on those 2 procedures. That's it for the coding. I also want to show you that you can save. You can save this code by hitting the save button. In SAS Studio, it saves it in our virtual project folder. Let's name this one SAS Intro. And in base SAS, it's pretty similar. You just do the same kind of thing, and it we have to tell it where to save it. Let's save it under SAS user here. Yes, in base SAS, you could do the same thing. Just hit the save button, tell it where you want to save it. It's a little more flexible. Actually, it's a lot more flexible in base SAS. You could save it on your C drive. You could save it on a network drive, wherever you want. Also, when you make these libraries up here, you can save those wherever you want as well. You're not limited by the virtual folders for SAS Studio. So lastly, I wanted to just mention that I'm going to put in a link in the description for a SAS Studio download, and if you don't have SAS, then that's a place where you can go and download it and install it, and just practice using some of these data sets, watch some more videos. I'm going to show you videos about how to import data, how to do statistics, how to do all kinds of things. So be sure to look out for more videos on SAS topics. And hopefully this gives you some fundamentals on how to get you started. And if you found this video useful, please like and subscribe. And thanks for watching.